Hello everyone, my name is K. Reddy, working as a assistant professor in Tegal Krishna Engineering College. Welcome to my channel. My channel name is Accelerative Research. This video I will explain power quality and fact subject. I will open this view playlist. These three videos are related to power quality and fact subject in Unit 1. This video I will explain power quality and fact subject Unit 2. This is the subject power quality and facts. This is JNQH R18 syllabus. In my last videos, I explained power quality problems in distribution system. This is total Unit 1. Now I will start Unit 2. Unit 2 is transmission lines and series and shunt reactive power compensation. This is transmission lines and series and shunt reactive power compensation. Next, in this second chapter, I have total 5 topics. One is the basics of AC transmission. Second topic, analysis of uncompensated AC transmission lines. Third topic, passive reactive power compensation. Next, shunt and series compensation at midpoint AC line. Fifth topic, comparison of series and shunt compensation. So now I will discuss analysis of uncompensated AC transmission lines. Okay, this is the topic. Okay, this is single paper. I covered total this analysis of uncompensated AC transmission lines. Okay, here this is the two system without compensator. Okay, in this two mission system without compensator, this is the circuit diagram A, this is the phasor diagram, this is the output waveforms of real and reactive power output waveforms. This is okay. First I will explain circuit. In the circuit of total three voltage source, three voltages. One is the Vs and Vm and Vr. Vs is the sending end voltage. Okay, this Vs is sending end voltage. This Vr is the receiving end voltage. This Vm is the midpoint voltage without compensator. Okay, Vs and Vm, Vr. This is the reactance. This total reactance X. Here Vs to Vm. This point up to half reactance X by 2. Here also half reactance means X by 2. Next, this is the current flowing from sending end to receiving end. Okay, these are the terms. Sending end voltage, receiving end voltage, and midpoint voltage without compensator. This is the phasor diagram. Here, this is the Vs sending end voltage. Vm is the midpoint voltage. This Vr is the receiving end voltage. Here, this Vx is equal to J into Xi. In the circuit, our resistance 0, R plus JXL. That's why here V is equal to IR for IZ formula. Okay, this is the imaginary part J into Xi. Okay, next here Vs to Vm, this angle is of delta by 2. Here also this Vm to Vr of angle delta by 2. Total Vs to Vr total angle is delta. Okay, here of delta by 2. This is the phasor diagram. Next, I will explain this mathematical formulas. This is the midpoint voltage Vm. Okay, this is the Vm. Here the sending end voltage. This is the receiving end voltage. Sending end voltage formula V angle theta. Here, this is the magnitude and phase angle theta. Here theta means here this triangle. Okay. Next, here Vs is equal to V cos del by 2 plus J sin del by 2. This is the sending end voltage. This is the receiving end voltage. Vr V cos del by 2 minus J sin del by 2. Okay, this is the Vs sending end voltage. This is the receiving end voltage. This is the Vm, this midpoint voltage. Vm is equal to Vr Vs plus Vr by 2. This is the formula. Midpoint of sending voltage of receiving end voltage. This Vm. Finally, after adding this Vs and Vr, after adding this supply sending end voltage and receiving end voltage, this total minus terms will cancel. Final formula Vm is equal to V cos del by 2. Okay, this is the midpoint voltage Vm. Next, current I have written as I is equal to Vs minus Vr by Jx. Okay, in this closed circuit, supply voltage Vs is equal to Vr plus J into Ix. This is the Kirchhoff voltage law formula. After calculating I is equal to Vs minus Vr by Jx. Okay, substituting in this current equation Vs and Vr. Finally, I got I is equal 2v into sine del by 2 by x. Okay. After substituting these two values, two formulas, Vs sending end voltage formula and receiving end voltage formula. Finally, I got this I is equal 2v sine of del by 2 by x. Okay, midpoint voltage. After calculating this midpoint voltage and current, I calculated here real power and reactive power. Real power formula P is equal to Vm into I. Okay, P this Vm formula V is equal to cos del by 2. I substitute here. Next current formula also I is equal to 2V sin del by 2 by x. This current formula also I substitute here. Okay, P is equal to Vm into I. Okay, next P is equal to this V into V2 2V square cos del by 2 into sin del by 2 by x. Okay. So one formula 2 cos theta into sin theta is equal to sin 2 theta. That formula I applied here. Finally, I got P is equal power P is equal to V square by x into sin del. Okay, this is the real power formula. Okay, real power in two machine system without compensation. Next, this is the reactive power formula. Reactive power Q is equal to VI into sin del. Next, Q is equal to V. Same V I also keep here. Next, current I is equal to V sin del by 2 by x. I substitute here. Next, sin del by 2. Okay, this is the next formula. Q is equal to V square into sin square of del by 2 by x. Okay. Next, I applied this formula. Sin square x is equal to 1 minus cos 2x by 2. This formula applied in this Q. Finally, reactive power form. Finally, I got reactive power. Q is equal to V square by x 1 minus cos del. Okay, this is the real power. This is the reactive power. Two powers I calculated. Finally, this is the output waveform of real and reactive power waveform. This x-axis is the del. This is the 90 degree. This is the 180 degrees pi. This is the 90 degrees. This is the del. Okay. Next here, this is the power maximum. Here, this is the real power P is equal to V square by x sin del. If we change delta angle, the power value also will change. Here also Q V square by x 1 minus cos del. If we change here this delta angle, the reactive power will increase. Okay, this is the active power. This is the reactive power doubles the reactive power doubles the real power. 2P maximum. Q is equal to V square by x 1 minus cos del. This is the total analysis of two mission system without compensator. In this topic only analysis of uncompensated AC transmission lines. Okay, this is the uncompensated. Uncompensated means here I did not include any shunt compensation, series compensation, shunt and series compensation. Okay, there is no compensating in this circuit. There is no compensation in the circuit. Okay, this is the total analysis. Only circuit diagram and formula. Okay, thank you for watching this video.